Welcome everyone to this explainer. Today we're tackling that classic, honestly kind of sleep-depriving dilemma that haunts pretty much every homeowner in an older neighborhood. We're talking about aging plumbing infrastructure, specifically that hidden labyrinth of sewer lines buried right beneath your lawn. I mean, if you own a home, you know exactly the kind of anxiety I'm talking about, right? You've probably heard the neighborhood gossip, the competing claims about which older pipe material is going to collapse on you first. Is it those vintage clay pipes or the heavy-duty cast iron? Well, today we're breaking down the facts directly from the experts to give you the ultimate answer.
So let's just ask the million-dollar question right out of the gate. Clay or cast iron? Which one breaks first? Think of this like a heavyweight boxing match taking place entirely underground. In one corner, we've got the rigid, historical champion, vitrified clay. And in the other corner, the heavy, metallic brawler, cast iron. But here's the thing. They aren't just fighting each other. Their actual opponent is the harsh, totally unforgiving environment of the Chicago suburbs. It is a brutal arena down there of shifting soils, freezing temperatures, and corrosive water. And the stakes here are, well, they're incredibly high for your wallet, your property value, and honestly, your home's structural stability. A failure in either of these lines can mean catastrophic backups in some wildly expensive emergency excavations. Now, the short answer to our big question might actually surprise you. Neither material always fails first. Because the main driver of failure isn't just some countdown timer based on the material itself. It's how that specific pipe behaves under stress. As we'll see, these two materials don't just fail at different times, they fail in completely different ways.
All right, part one, the great pipe debate. Let's dismantle this suburban plumbing myth.
Starting with clay. Cracks under pressure. This is what happens when a rigid material meets shifting ground. So on paper, clay is highly durable, but it is extremely unforgiving. Let's look at exactly how it fails, because it's essentially a rapid, compounding chain reaction. Step 1, the ground shifts even just a little bit, or maybe there's an imperfect joint from the original installation decades ago. Step 2, because clay literally cannot flex, tiny hairline cracks form, usually right at those joints. Step 3, water gets in. Just a little moisture infiltrates through that crack, and it starts washing away the supportive backfill soil around the pipe, stripping away its structural support. And then we hit step 4, which is the fatal blow. In our freeze-thaw climate, that moisture freezes. It expands rapidly, forcing the crack wider. Then it thaws, then it freezes again. This relentless cycle violently and suddenly shatters the compromised pipe. It's a fast, sharp, early failure mechanism. Once a tiny defect forms, that freeze-thaw cycle acts like a wedge, just blowing the pipe apart way earlier than you might expect.
Now for our other contender, cast iron, the slow decay, the silent buildup of scale and corrosion. If clay is a sudden shatter, cast iron is a slow, creeping decay. The silent killer here is internal corrosion and the loss of wall thickness. Even when a cast iron pipe looks totally fine, perfectly structurally sound from the outside, there's a sinister process called turbulation happening on the inside. Basically, turbulation is the gradual buildup of scale and rust that slowly roughens the pipe's interior. Over time, this buildup just gets thicker and thicker, severely narrowing the pipe's flow capacity. It's exactly like arteries clogging. As that capacity shrinks, the line becomes highly prone to surcharging and backups, especially during heavy rain events. This corrosion literally eats away at the pipe from the inside out. And that process accelerates depending on just how corrosive your local groundwater and soil chemistry happens to be.
And this brilliantly illustrates the core difference between our two materials. With clay, it's highly prone to early cracking and joint infiltration, the absolute second it faces physical stress or shifting ground. But with cast iron, it's prone to a much more gradual, silent internal corrosion and capacity loss that tends to present as a failure much later on. So think of it like this. Clay fails from the outside in, due to movement, while cast iron fails from the inside out, due to chemistry.
Which brings us to the true underground culprits, the plot twist beneath your feet.
All right, here is the real aha pivot of this entire explainer. The material written on your home's blueprint, it actually matters way less than you think. The real enemies are the environmental triggers and the original construction quality of the Chicago suburbs. These are equal opportunity destroyers. They ruin both pipes indiscriminately. We're talking about aggressive tree roots seeking moisture. We're talking about heavy construction vibration from nearby roadwork or differential settlement of the soil. But, it's also about human error from decades ago. Things like poorly compacted trenches, inaccurate grading where water doesn't flow right, or older patch sections where plumbers tried to connect clay to cast iron using lead or wrap materials that have just degraded over the years.
Two neighboring homes with the exact same pipe material can fail decades apart, simply because one had a poorly compacted trench and aggressive tree roots, while the other sat in nice, stable soil. The local environment is the true heavyweight champion here.
Now, what's really interesting about this is that when we look at the hard visual evidence from CCTV cameras, it backs this all up. This isn't just theory. This is exactly what crews see when they send cameras down into these systems. If you've got clay pipe, inspectors are almost always logging offset joints, severe cracking, and water infiltration right at the connection points. But if they drop a camera into a cast iron system, the screen shows a totally different horror story. They see heavy internal corrosion, that bumpy tuberculation scale we talked about earlier, and massive structural breakdown concentrated in the low points where corrosive water just sits and eats away at the metal.
So, what do? Inspect, do not guess. Let's talk about how to actually protect your property.
How do you protect your property and, frankly, your sanity? I absolutely love this takeaway from our source material. It says, the most useful next step is usually not the material label on paper, but a condition assessment. Guessing your pipe's health just because you know it's clay or cast iron is a huge mistake. The real winner of this debate, or I guess the loser, is simply determined by which mechanism of decay managed to start first in your specific yard.
So the crucial point is this. If you want to know what's really going on, you've got to get a proper condition assessment. This means hiring a pro to do a full camera or CCTV inspection to look for those cracks or that nasty tuberculation. It means doing a leak and infiltration evaluation to see if water is washing away your backfill. And crucially, it requires a review of your specific, localized soil and groundwater conditions. Are you in a highly corrosive soil pocket? Do you get heavy freeze-thaw movement? These 4 steps are literally the only way to accurately map out what risks are emerging in your unique system.
Which leaves us with one final, totally unavoidable question. What might be lurking directly beneath your feet right now? Is a hairline crack in a clay joint just waiting for the next deep freeze? Or is silent tuberculation slowly choking off your cast iron line? Do not wait for a catastrophic backup to find out. Take control, get an inspection, and know for sure. Thank you so much for joining me for this explainer. Until next time, keep learning, keep questioning, and definitely keep an eye on your plumbing.